Whoa, what happened here? Back to the front part here. Hi, everybody. This is Mr. Folly, and welcome to part two of our kinetics unit. So we're going to start off with potential energy diagram. So we did this before when we did combustion. And when we did combustion, we identified reactions as exothermic and endothermic, right? So then I'm going to label all the parts that are on here. Now, I added a few more type things than what is in your printed out version, so make sure you have it all in there. I think I highlighted in yellow what I added. But right here, the starting substances would be the reactants. That's weird. So let me do this. Reactants. Products are the ending substances, so these are the products. And you'd write them right on the line. These are physical things. The transition state. So the activated complex is the temporary arrangement, that's funny, of atoms as a transition state between reactants and products. It is represented at the top of the potential energy hill. So that means the very top right here, we have the transition state. It's also called the activated complex. They're exactly the same thing for this class. All right. Activation energy. Oops, it's got a little jumbled. Activation energy, EA. So it's energy of activation. Is the energy to get from the reactants to the highest hump. The activation energy, EA, is the minimum energy the reactant molecules must possess in order to have successful collision to form the activated complex, and then eventually the product. So notice it's a minimum, so you can't have too much energy. That's like being too smart or too pretty. You can't have too much energy, can't be too smart, can't be too pretty. Delta H, energy from the reactants to the products. So it's going to be the products minus reactants. So looking right here, my products right here to my reactants. So that would be products to my reactants. That would be the D part right here. Okay, so if I put numbers on here, and I didn't, but if I did, if this was 25 and this was 600, right? Oops, 600. Let me try again to write a number that's legible. 600. I would do products 25 minus reactants 600, and I would get negative 575 kilojoules. And that would be exothermic because it ends up going down. It's negative if it goes down, positive if it ends up. So what it looks like if it ends up would be this. All right. Endothermic, energy change where products have more energy than reactants. Products have more energy than reactants. That's why it's endo. It ends higher. It absorbs heat. The product will be colder because it absorbs the heat. And exothermic, energy change is where the reactants have more energy than the products. It ends lower. It produces heat. You know what? I've changed the word produces to releases. The products will be hotter. A catalyst speeds up the reaction in both directions. It lowers the hump. It's shown as a dashed line like a tunnel. So I talk about how I drive from Indiana to Illinois most every day, and I have to drive over Mount Hoosier. So if I thought of this as being Mount Hoosier, and then the great state of Illinois spent $475 million making a tunnel for Mount Hoosier, so it would be faster. So notice it's faster for me to go from the great state of Indiana to Illinois, and it would also be faster for me to go from Illinois to Indiana because I could take the tunnel going both ways, right? So it's faster in both directions. So when this happens, it actually changes the mechanism. So you know how like before it was climbing over a mountain, the mechanism change would be like flying over a mountain in a helicopter or riding a horse or something like that. It doesn't just lower the energy of the old mechanism. That's how it works like in real chemistry. But just lowering the dashed line is all you need to worry about. A catalyst affects the slowest step of the reaction. The catalyst changes the mechanism, and like I said before, walking versus airplane. So, reverse reaction. Start on the right and go left. Endo, exo flip, delta H flips. So, here we go. We got this. It's absorbing energy. As you go up, you're absorbing energy. as you go down, you're releasing energy. So you should be able to label that, and that was on your test before. So let's take a look. Let's get some numbers. So this is the forward for reverse, and that should be forward. I see what I did there. That was so not funny. Okay, so reactants are 40 kilojoules. My products are 125. So let me show you how I'm getting this. Here are my reactants. That's 40. Here are my products. That's 125. EA is not from the ground to the top. No, 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 no. EA is from the reactants to the top. So 335 minus 40 equals 295. The transition state is that number. This is my transition state, AC, is 335. And remember, delta H is products minus reactants. So it's going to be 125 minus 40, which is going to be, and I like to emphasize the positive 85. Check my units. You better check yourself before you wreck yourself. And we're good. Now for the reverse reaction. So we're just going to ask you about a reverse reaction. So here it is. What about reverse? Many reactions are reversible. So in this case, my reactants, I'm going to change my color from black. Let's go to the evil of the red. Yeah. So these would be my reactants now. So my reactants are going to be 125. My products are going to be this part here now, 40. My EA is from 125 to 335. 335 minus 125 equals, what is that, 110? Oop, forgot my units. Transition state is the same. So the transition state is still 335. And the delta H is going to be the same, but the sign will flip. So it's going to be negative 85 kilojoules now. And what this has, you see how it's got yet another highlighting color. Ooh, how fancy. See how this has a catalyst here? This would, oh man, it says it's on the pencil. This right here is a catalyst. And that catalyst, everything else is the same, and it lowers both EAs. So the activation energy for the forward reaction would be, so catalyzed is 190 minus 40. Kilojoules. And the catalyzed for the reverse reaction would be 190 minus 125. So again, notice how, let's see what that be, 65. So notice how that changes this number right here. Okay. Good. That's it in 8.5 minutes. How about that? Can't beat that with a stick. Toodles.